All right, so now, so far we've used step 1, solving for rotational, step 2, solving for vertical translational. Now we are going to include a horizontal component. Could we actually please go to this question on the next page, the angled example? Because it turns out this question is actually a little bit easier than the other. So, there will be a tension acting along the cable. It's going to provide a counterclockwise torque to overcome the torque produced by the weight of the beam, which I've got down here as 200 newtons. And there may be a mass hanging off the end of the beam of 1000 newtons. Now we're going to place our pivot point down here where the beam is attached to the wall. Okay, I need to give you some information. Let's just say that the beam is 4 meters long, such that, and it's uniform, such that its center of mass acts midway along 2 meters. Then the 1000 Newton weight at the end is acting 4 meters along. Now, here is where we run a risk. We've got theta and theta. Both those angles to the vertical are the same, but then the angle for tension in this scenario is going to be the complement. It's not always going to be the complement, but I've just chosen that the cable is horizontal. And so now you've got between the weight force acting down and the tension acting horizontal, you've got a right angle such that phi and theta must sum to 90. So this is a common mistake. Students just jump into sine theta plus sine theta equals sine theta. No, you've got to make sure you've got the right angle. Okay? So, last thing we're going to do, let's put in 40 degrees for theta. And then phi is 50 degrees. Okay? So far, so good. We haven't, well, let's just do step 1 as we always would. Sum of all torque equals 0. Torque equals RF sine theta. Clockwise moment equals anti-clockwise moment. Or taking moment about P. I've identified the pivot point on my question. Now, I'm just going to do a little mid-step here. R1, weight 1, sine theta, plus R2, weight 2, sine theta, equals R2T sine phi. Okay? So, again, lots of students in this kind of scenario, they use one angle for both. So you just have to be careful that you're using sine 40 and sine 50 in the appropriate areas. Yes?
Is that a line of working out to put down?
Well, in this case, I would encourage you to. You've already got... Oh, no, I thought I was in highlighter mode. You've already got that statement at the top, okay? So I'm fine for you to go into the maths. But for this, it pays just because we've got a slightly more difficult scenario. So 200 sine 40 plus 4 by 1000 sine 40 equals 4t sine 50. Okay? Now I'll just stop it here and say that the total clockwise moment caused by the beam and the mass is 2,828 Newton meters clockwise. The cable acting 4 meters at an angle of 50 must also produce 2,828. So therefore T equals 2828 over 4 sine 50 equals 923 newtons through the cable. Okay, so we can now say 923 newtons. Just on that, remember, look at the proportionality. The tension is dependent on the moment that it needs to produce, inverse to the radius. If we increase R, the required T goes down. That makes sense. The further along the beam we can mount our cable, the less tension will be required. And also it's an inverse to sine theta. So again, the perpendicular would be the least tension. If I could get my cable to be 90 degrees to the plank, that would produce the least tension. Well, maybe we can't mount our cable at that angle. Maybe we are limited by the building that it's attached to, okay? So obviously, again, as theta gets smaller, right, as we reduce that angle, tension's going to increase, okay? So imagine it would be very silly to try and mount a cable like that. If you made this, I don't know, 2 degrees, anything divided by sine 2, tension's going to be getting really, really large, and the cable won't be able to handle that. Okay? Now, what's happening here? I've identified 3 forces acting on this beam. Tension's acting in, weights are acting down. If those were the only 3 forces, then there would be an unbalanced net force acting down and in. Yeah? The beam would sort of fall down and in. Well, at the pivot, there is a reaction force. It is going to have to act up and out. Okay? So it has to have an upwards component to balance the downwards weight forces, and it now has to have an outwards component to balance the inwards of tension. Okay? This is where we have to now look at step 2 and step 3. In this scenario, your trestle table or your painter's scaffold or a very simple seesaw, there's no horizontal. The reaction force at the pivot is acting straight up, and you've got your weight forces acting straight down. Now we're going to add a horizontal. So, at the bottom of the page, step 2. Our equation gets slightly more complicated, but not much. Sum of all forces in y equals 0 equals weight 1 plus weight 2 plus FRY. Now, I'll identify that on my diagram. FRY and FRX. Okay? Assign a convention. We'll say that down is negative. Therefore, 0 equals negative 200 plus negative 1,000 plus FRY. FRY equals plus 1,200. Okay, so that is our component. And again, it should make sense that this vertical arrow, this vertical component must be equal and opposite to the 2 downs. So if we've got a downwards sum of 1,200, then the upwards sum must also be 1,200. Please, again, I've written this before. Do not write the sum of the ups equals the sum of the downs. Just, you go straight to that. That is worth marks. Now let's bring in step 3. This one's a little bit easier. The sum of all forces in the x equals 0, which is equal to T plus FRY. I might say that FRX, thank you. I might say that left is negative, right is positive, in which case in our diagram tension is negative. Therefore, FRX equals negative T equals plus 923 newtons. Okay? Then, last step. We've found both the components, the vertical component and the horizontal component. We now need to simply combine them both using Pythagoras and tan. Okay, so we've got plus 923, plus 1200, and theta. Yes, Rahal, what is it?
In the first step for part 2, can we just say sigma mg is equal to the reaction force in y?
No. You write the sum of all forces in the y equals 0, and then you state the forces that are acting in the vertical. Okay, which is that. All of that. vector 1, add vector 2, add vector 3, add vector 4, add as many vectors in that plane as are acting, sum them together, equate them to 0. Okay? All right. We get a reaction force of 151 times 10 to the 3 newtons. Our angle is 52.4 degrees. Could you please write? You cannot talk and write at the same time. I can.
923 on 1200 is 3716. So
Thank you. I'm trying to erase that.
just black mark it out. Can you use the other angle if you specify that it's from the vertical?
Yeah, you could, but I'd rather find the angle to the horizontal. Opposite 1200 over 923. Okay, FR equals 1.51, 10 to the 3 newtons, right at 52.4 degrees above horizontal. Okay. Please do not just say 52 degrees above horizontal because there are two. There's one going right and one going left. All right. You could say out from the wall, but you can use the direction as given in the diagram. So if you have a diagram, right, left, up, down. Okay. Now, the reason why I should have put this question first because it actually turns out to be a little bit easier than the previous question. Could we now go back to